a plugin for openQRM which interacts with the virtualization layer. This layer provides support for transparent migration from physical to virtual machines. How we are doing this? In openQRM, I just said it before, everything is managed by net booting, and we also took the appliance-based deployment, and openQRM provides utilities to capture existing servers and transform it to a server image, which is then hosted or located on a storage server. And from this point, it can deploy this server image to either physical resources, like my physical hardware, or virtual machines from any type. The server images or an image-based deployment has some more advantages, not only for the virtualization, but also those server images I can create, and those are known to work images. For example, I have a web server image which acts as a kind of template. I know that this image works fine, and when I'm deploying it, I can just say to openQRM, use this web server image on the remote storage and deploy it to my physical machine over there, or deploy it to my virtual machine inside some hypervisor without any changes on the server image itself. It means the migration from physical to virtual is completely transparent. Storage integration is a big deal especially for virtualization and for this image-based deployment, because the server images are located on big storage servers, and these storage servers are providing features like fast cloning. For example, NetApp or with LVM2, we can clone or snapshot existing images and use this snapshot to deploy them. This means we're coming to a point of a mechanism called golden images, or we call it golden images, meaning having several server templates which are never going to be deployed directly to physical or virtual machines, but they are cloned in the moment they should be deployed, and then the snapshot is deployed instead of the real template. So I'm never touching a template anymore, but I'm just cloning, or openQRM just clones existing server templates on the fly during deployment, and then deploys the snapshot. This has several advantages. First, the snapshot does normally not take all the space like the full image, but only the change bits are being saved on the storage server. And the second, I already have my server images then on the central storage, which is the great place for backup and restore. openQRM itself can automate this deployment, and initiated by network booting, it can deploy those server images on the fly, which means deployment time in openQRM becomes boot time of the system, because the cloning procedure does not take a second, and when the image is ready, it can just be deployed during boot up. Let me just lose some words about deployment methods. I said that we are using network booting to control the nodes or the servers, either physical or virtual. We have different deployment methods based on this net booting. First is NFS root, everybody knows it. Has its advantages, it's very flexible, has also its disadvantages. Not everybody likes NFS. We also provide a feature called iSCSI boot. It's quite new mechanism. iSCSI is a new storage server type which does which offers a remote block access to a remote block device via the SCSI protocol on top of IP. So with the openQRM iSCSI deployment method, we can get rid of all disadvantages known by the NFS deployment, and also benefit from having a standard file system like extended3 or RiserFS on the block device, which then is attached during deployment from the storage server to the physical system via network, and the physical system just, or the deployed system just sees this remote block device as a local SCSI disk, and especially because of the internal file system caching of extended3 and RiserFS, for example, you get a much better performance than compared to NFS root, because when on NFS every read and write goes immediately through the wire. With iSCSI root, the reads and writes, for example, are going through the file system cache, and the system will write it through the wire when it has time. So you gain some performance through that. We also have a deployment method called a local deploy. Means we take a local disk image dump, put it on the storage server. This is the gathering stage for creating a server image, and then openQRM can dump or restore this disk dump to any of the available systems again for deployment. The fourth deployment method in openQRM is local installation. We integrated with Linux.conf.au, which provides a kind of auto installation for different Linux distribution, and all those deployment methods can be used for either physical or virtual machines. So in general, openQRM is not only a GUI for a virtualization host, but it's a deployment system which also can deploy your hypervisors, like the Xen host or VMware host. And while deploying them, you can directly manage the virtual machines on the virtualization hosts. openQRM also can create clusters on the fly, meaning with openQRM I can create very easily a cluster of shared Xen hosts, all using the same file system image. So it's a single system image cluster of Xen hosts, and on each of the resources of the physical machines inside this cluster, partitions can be created and being managed and also live migrated from one system to another within the single system image cluster. This is all good for load balancing and scalability. This clusters of shared hosts, of shared virtualization hosts, they can scale up and down automatically. That means if more virtual machines should be added, we can, and the cluster itself cannot stand the load anymore, we can just add nodes, physical nodes to the cluster, and then create new partitions or new virtual machines on this specific host, or migrate existing virtual machines from loaded virtual hosts to less loaded Xen hosts.